Welcome back to our Software Design Development unit. In this lesson we will look at sequential file operations. Our learning intentions for this lesson are as follows. We'll learn the process of data transfer to and from a file, learn how data is read into a program using sequential file handling, and we'll learn how data is written out to a file from a program using sequential file handling. As always, we have some success criteria. For this lesson, our success criteria is as follows. We'll be able to describe how data is transferred to and from a file. We'll be able to read data into a data structure from a file in a program, and we'll be able to write data out to a file from a data structure in a program. In this lesson, we'll look at how we can enter data directly into a text or CSV data file and load that into a program. When we create an application that uses data, we would load that data from a file into a data structure such as an array when the program is run. We would then write that data back to file from the array when the program is exited. When a program is to read or write data to or from a file, a series of activities must be followed. Firstly, the operating system must be supplied with the location and name of the file. Secondly, the data can be read from the file by the program to the appropriate storage in memory. And finally, after the data from the file has been copied to memory, the link to the file is terminated. We can see these logical steps here. When we read data from a file into a data structure such as an array, we must prepare the file for access using the file open statement. This requires three pieces of information. Each file we use within the program must have a unique file number, and the file must be identified by that number. The first file would normally be number 1, and all open files must be identified by different numbers, so therefore a second file would be given the file number of 2. They must be given a file name, and that includes the path and file name of the file to open. And this is what will be identified by the file number you specified. And then finally, the access mode, and that indicates if the file is to be opened for reading or writing. We can see examples here. So when we're transferring data from a file into a data structure like an array, the contents of the file are read into memory a field at a time. This is achieved in Visual Basic using the input statement. The file number identifies the file to read from, and the destination specifies the data structure the data is to be read into. Let's look at an example file. Currently this file contains 10 records numbered as we can see in the picture, and each record has 3 fields. The end of the file is indicated by a special character called an end of file marker. Visual Basic maintains a file pointer to indicate where the next item to be read from the file is. When a file is opened, the file pointer is at the start of the file and is advanced 1 field every time a read takes place. In this way, the data can be read from a file by repeatedly reading from the file until the file pointer reaches the end of file marker. This is done, as we said, 1 field at a time, progressing through the entire file until the file pointer reaches that end of file marker when it knows there is no more data to be read. Let's look now at transferring data into parallel arrays. The data in the file must be in the same order of the data structure it's being read into. If not, a potential error may occur due to a mismatch in data types. We'll look at an example of some code. The conditional loop will iterate while we are not at the end of file. We use the input command to input the data sequentially from the file into each array element using the running total I to determine the index of the element. This will iterate and input the initial, the surname and age into each element of the parallel arrays. Again, using I as the reference to the index. Transferring data from a file into arrays of records is very similar. The conditional loop will read the file into an array of records. We have another dimension to consider now. We must consider the index and the field for each record in the array. Again, we will use the input statement, and the index will be incremented by the running total I being increased during every iteration of the loop. We can see that extra dimension we must consider .initial, .surname, .age for an array of records called people. Let's now look at an example. We have a text file called people.txt and an array of records called people. We also have the code that we will use to transfer the data from the file to the array of records. We will step through this code, visually seeing how the data is transferred. We will start our iteration, and we will do this while we are not at the end of file 1, which is our people.txt file. Using the input command, we will input data from the file 1, which is people.txt, to our array of records people index I, which in this case is 0. So that data is then transferred. The indicator moves up the file, transferring each field of information as we go through our input statements. At this point, I is incremented by 1, making it now the value 1, and we will go through our second iteration. We will now input the .initial field into index 1 of our array of records. Surname, age, before we increment to 2, round the loop to iterate again, adding our fields of information to our array of records, again adding 1 to a running total I, now value 3, before we iterate through the loop again, adding our fields of information as we go. and this process continues until we reach the end of the file and ultimately populate our array of records. Let's now look at the opposite, writing data to a file from a data structure like an array. When a programmer writes data to a file, a series of activities must be followed. First, the operating system must be supplied with the location and name of the file. Secondly, the array will be traversed to access each location sequentially. Third, each record will be written to the file. And finally, after the data from the array has been written to the file, the link to the file is terminated. We can see these logical steps now in our example. When reading data from array to file, we must prepare the file for access using the file open statement. And again, this requires three pieces of information. The file number, again, that file must be identified by a number. All open files must be identified by different numbers or unique numbers. And having a second file open would be given the file number, number 2. We'd also need the file name, the path and file name of the file to open. And that's what would be identified by your file number, and the access mode. And that indicates if the file is to be open for writing. We can see this in this example here. We have a new file, which is file number 2. We've given it its path and file name, which is newfile.txt, and its open mode is output. Again, when we're writing from a data structure to a file, we would use the with and end with statement. And that's a statement that will repeatedly refer to a single object. In our case, this would be our array of records. We would also use the write line statement to output data to the file. The write line statement writes the specified data items to the file and separates them in the file with commas. We can see an example of the logic here. Let's look at an example of writing data from an array of records out to a data file. Again, we have an array of records called people, our data file called people.txt, which has been allocated the file number 2. We've got a fixed loop here because we know how many pieces of data we want to output. So we have 10 indexes that we want to output. As we mentioned in the last slide, we'll use the with end with statement with our array of records name, which is people, and we will refer to that constantly using its index reference, which in this case is I also, which is controlled by the loop variable I as it increments and iterates around the loop. We will then use the write line to output our data to file. So we start our loop, we refer to our array of records and index. We are suggesting we're going to write to file number 2 the fields initial, surname and age, which we do sequentially. End the statement, and we then iterate around the loop with I incrementing. So again, we refer to our array of records. Our index has been incremented by 1 to the value 1, and again we use our write line statement to file number 2, the fields initial, surname and age. Sequentially, those are written out to file. and this continues until our file is completely populated.